Okay, colleagues here, software engineers shall be fair and supportive to their colleagues. If they are not able to get some answers, okay, they'll be going to stuck with their colleagues, stuck with some problem statements, okay, solutions they are finding it. That time you should help them, okay, so that they should be supportive to the colleagues. Then you should also grow according to the project that will be given. So you should also grow, and others also you should make to grow it. Okay, in the learning concepts, every day that you should learn and you have to practice it. That is the good profession that you have to make it. These are the 8 ethical principles. It is being provided by the IEEE ACM and IEEE CS. Okay. Some of the case studies are going to be there. In that, first is insulin pump. Okay, that is going to be used for it is an embedded system. Basically, is used for the insulin pump is used to diabetics to maintain the blood glucose control. For this purpose, the insulin pump is being used. How it is going to be? So we'll study in detail. Then mental health care. Health case it is healthcare. Patient monitoring system or management system, you can say. So how we will be going to mental care, that is one software is going to be there. Okay, those things will be going to deal with different records are going to be there. Based on that records, how we will be going to manage this mental health person or patient. Then weather station, weather forecasting station will be there. Wilderness weather station, this is another case study. It is going to be with the remote access and how we will be going to collect the data that it is. Then another is iLearn, is a digital learning environment platform it is. So how it is going to get support for the schools and colleges. Okay, insulin pump, how it controls basically. Here is the diagram. We'll go for the diagram first. Here it is. Okay, is the insulin hardware architecture it is. There's you can see that insulin reservoir is there, pump is there, controller is there. Okay, clock, alarms. Then we have displays, then sensors are there. Needy assembly means it is a pump, how we should pump it. Then power supply. Without power supply we cannot do anything, right? So pump needs the power supply and all these things. It is connected with the insulin reservoir where you can suck the insulin, and based on the control structure, control data, the information is going to be provided. How much insulin is needed for that particular patient. So first to know that sensor is going to sense it. Okay, then the alarm has to ring. Okay, then it should be alert, the alert messages will be given. Then time is going to be the controller. That is what the important thing is. Time is very, very important thing. Clock is going to be controlled over here and it is going to be displayed. So based on the controlling structure, control information, the pump is going to suck the insulin and it is going to inject to the patient. Okay, so this is overall assembly of that particular architecture, we can say, with the insulin pump. I think now you understood what exactly that insulin pump is going to do it. First is collect the data from the blood sugar sensor and calculate the amount of insulin it is required for it is to be injected. That's what I said. So sensors are going to collect the information first here with the controller. Pump, it needs that information and sucks that to the injection. So it is going to be injected to the patient. Calculation based on the rate of change of blood sugar levels. So there's a functionality is there. Though based on that functionality, that it is going to be get controlled in that. Sends the signals to the micro pump delivery to correct the dosage of insulin. So here the control is going to give the instructions to the pump, correct the proper dosage, and you should inject it. Then fourth one, safety critical systems. as low blood pressure, if it is going to occur, then it is going to be brain malfunctioning, then coma it goes, even it is going to get to death. Okay, so high blood pressure, if it is going to be, then long-term consequences, kidney damages and all these things are going to be there. So for this, the displays are going to be always, it will be alarming, like, okay, so it is going to show you that whether it is a low blood sugar is there or high blood sugar is there, those things. Based on that, the controller is going to give the instructions to the pump how much it should inject, okay, whether it should be injected or should be ejected based on the sensor data that it is getting executed here. So how the same thing that it is getting repeated here also is the activity model. It is going to be, why it is going to be called as activity model is, so activity diagram it is, you can able to see here, okay, you can able to see here there is a circle with field 1 is there, and here double circle with one single field 1 is there. So this is a start, single field circle is start 1 and double circle is a stop 1. Okay, so now here you see that same information, what that I can call it as a algorithm, here I can call it as a, we can say, activity diagram it is. Okay, blood sensor senses that data and analyzes the sensor reading, then it should be given blood sugar, it should be checked, then compute the insulin, if whether it is high or low, that it has been computed and it should be given to the insulin dose. So if the dose is going to be log, always it is going to be get checked, that is a log is going to be maintained. Okay. So always that it is going to be get checked, that's why it's the circular way that checking is going to be done in this insulin log. Again compute that, it is going to be given. Then insulin dose, once if it is high, okay, or if it is going to be low, that time it should be injected. So give the compute pump commands. So how much dose that is required, that instruction should be given to the pump. Then pump data is going to take that, then control the insulin pump. So instructions will be given like that. Then insulin pump is going to take that and it should get injected. Okay. High level requirements of this. This is nothing but a high level only. So whatever the diagrams you'll be going to, it is going to appear. Those are the high level requirements. Okay. So first is the system should be available to deliver the insulin whenever that is required. First thing it is. Then it should be reliably and deliver to the correct amount of insulin. Okay, if the blood sugar is going to be high, then you should not give any dosage of that. Okay, if it is going to be low, and you should calculate, basically you should calculate reliably, you should calculate, and the correct amount of insulin should be given. Okay, then the system must therefore be designed in such a way that it should meet the requirements. What is the requirements? The calculations. Based on the proper calculations, the doctor specifications, the calculations are going to be met properly, then only those dosages are going to be given. Those instructions are going to be set in the system, then only it will be correct. Okay, so these things are going to be the high level requirements of particular software. This is another one case study. Mental care system, it is going to be mental health information system. How this a patient information system is going to be there, which supports the mental health care medical information. So about the patient, all the problems whatever that he is facing, that is being recorded and it is going to be kept. Treatments and all these things are going to be. Then the patient, he is not required any dedicated hospital treatment. If sometimes, okay, then only special doctors are going to be treated whenever that it is required. Then only the doctor can meet. At that time, the problems are going to be diagnosed based on the previous history. So the records have been kept.